Hello, welcome. Today we are going to talk about a new subject. It's called arithmetic series. So let's get into it here. Oh, let's go back. There we go. Suppose you wanted to know, I gotta go back 1 second. Suppose a movie theater can seat 4 people in the first row. Let's see if I can draw it out so you can really see it. There's 4 people in the first row and 7 more people in the second row. I'll just draw it, 10, and 7 more people, so that would be 17 in the third row, and then on for 9 rows. Well, how many people can the 9th row seat? Okay, just the 9th row. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That 9th row is going to be really big, right? Imagine these were all big. Okay, let's get into it. How many people can the 9th row seat? Well, based on the homework that you did yesterday, that answer is pretty easy. I'll just uncover it. Let's see. This is the series. We've got 4 in the first row, 11 in the second, 18 in the third. This is a sub 1. This is a sub 9. Okay, how do we figure it out? Well, we say that in the 9th row, we have, that's a sub 9. That's equal to a sub 1 plus the common difference times n minus 1. And that n minus 1 is the number of jumps to get here. So 8 jumps to get from 4 to 60. Okay? Answer, all we do is we plug in what we know. We know that a sub 1 is 4. The common difference is 7. N minus 1, well, n is 9. There's 9 different terms. So 8, so that would be 9. You got to erase. That would be 9 minus 1, or 8. So that equals 4 plus 7 times 8. That's 4 plus 56, which is 60. Okay. Now suppose you wanted to know how many total seats the movie theater can hold if it just has those 9 rows. Well, you could add up all the 9 terms. You could figure out what each term is and then plug it into a calculator and add it up. But here's another way to do it. It's a shortcut method, and it's going to help us find an equation. Imagine if you did this. Okay? Let's say that we take this series. Oh, by the way, let me explain something real quick. Difference between a series and a sequence. A series is when you add up all the terms in the sequence. The sequence was just, sequence looked like this. There were commas in between them. Okay? Series, they're all added. Good? Okay, let's say that you say the series looks like this in one direction, but we could also rearrange everything and make it look like this. Do you see any patterns? Can you find the number 64 here anywhere? Where is it? Look at this. Do you see 64? If we do this trick, do you see how all those add up to 64? And why this becomes 2 times the sum of those 9 terms. Okay, well, look what we can do with that. What we can do with that is say that this is just the same thing as 9 times 64. And if we divide both sides by 2, we end up with 9 halves times 64. Okay, let's review a little bit about what we know and see if we can come up with a general equation for a series. What was a sub 1? 4. What was a sub 9? 60. How many terms did we have? N was equal to 9. Okay, let's see where all of that is in here. We could say the general equation for a series is S sub n, that's the sum of all the terms up to n, equals, where did 9 come from? Well, 9 is just n over 2 times, where did 64 come from? 64 is the sum of the first term plus the last term. That would be a sub 1 plus a sub n. First term plus the last term times the number of terms divided by 2. Think of it this way. Here's another way of thinking of it. If you wanted to find the sum of this top, what you could do is you could say, what's the average of the first term and the last term? Well, the average is a sub 1 plus a sub 2 over 2. And if you take that average and you multiply it by the number of terms you have, that becomes your series, S sub n. Can you see that these two equations are equivalent? It's just two ways of thinking of the same thing. You have n over 2 times a sub 1 plus a sub 2. Okay. So here's the equation that you really do need to know. You can memorize it or you can just derive it in your head. Let's try this problem. Find the sum of the first 50 positive integers. Well, first let's figure out what are the first 50 positive integers. That would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Do I need to go on? Dot, 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 dot. Okay, I've got 5 of these integers here. 5 here, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. The last one would be here. What would the last one be if this is a 100 chart? 100, of course. All right, so let's figure out what do we know. What's a sub 1? 2. What's a sub 50? What's the 50th term? 100. How many terms do we have? Well, we've got 50. Can we figure out S of n? Of course we can. This equals 50 over 2 times 2. That's your a sub 1 plus 100. And that equals 25 times 102. And if you have your calculator, which I don't have, let's see if I can find it. Let's figure out what it is. 102 times 25. Should be 2,550. All right. Let's try something a little bit more challenging. Just going to clear a few things away. Using the same example from before, what happens if we know the first term? The first term was 4. We don't know the last term, a sub 9. That's a question mark. We do know n. We know there's 9 terms. We know that the common difference was 7. And we want to find S sub n. Let me just point something out here. We've got 5 different variables, okay? In these problems, you're always going to have the same 5 variables, so it's a really good idea to write them all down, say what you know and what you don't know. Put a star next to what you're looking for your very final answer. That's the real goal, okay? Now, let's see how we can figure this out. Let's use the formula that we just learned, okay? S sub n is going to equal n over 2 times a sub 1 plus a sub 2. Let's fill in everything we know. This is going to equal 9 over 2 times 4 plus a sub 2. Okay, we got a problem. We don't know a sub 2. So now we have to go to last night's equation. All you need are these two equations. I don't know why I put a sub 2. It should be a sub 9. Let's try it again. A sub 9, a sub 9. Good? So a sub 9 is equal to a sub 1 plus the common difference times n minus 1. Right? If we plug in everything we know here, you end up with 4 plus 7 times 9 minus 1. We already figured this out in the last problem. That's 60. So now we can plug this in here, and we're back to where we started just a few slides ago. Good? You have to get really good at this substitution. If you follow this protocol where we write down both equations, fill in everything you know, you're going to be fine. Okay? Let's try this one. Aiden did push-ups every day in March. He started on March 1st and increased the number of push-ups done each day by 1. He did a total of 1,085 push-ups for the month. How many push-ups did Aiden do on March 1st? Okay, let's start by talking about what do we know. Here are all my variables. We've got a sub 1, the first term, the last term, the total number of terms, the sum of all those terms, and the common difference. Which of these do we know? And what are we looking for? How many push-ups did Aiden do on March 1st? That's a sub 1. That's what we're looking for. So that one's a question mark for sure. He did push-ups every day in March. So how many n's are we talking about? How many terms in the series? 31 days in March. Okay. He increased the number of push-ups done each day by 1. What does that 1 plug in for? What is that? That's the common difference. He did a total of 1,085 push-ups for the month. What does that plug in for? Oh, that's easy. That's 1,085. Okay. Do we know a sub n? No. That one we leave as a question mark. All right. Now, how can we find a sub 1? Well, which equation should we start with? We know that we know the total number. So let's start with s sub n equals n over 2 times a sub 1 plus a sub, do we know n? We can change this from a sub n, see if I can erase it, to a sub 31. Because we know that the 31st one is the last one now, okay? All right, what do we know here? Well, we know that 1,085 is equal to 31 over 2 times a sub 1 plus a sub 31. Good? Okay, second equation. Looks like I better move my comic out of the way. Let's move it down here. Second equation. Let's try a sub 31 equals a sub 1 plus the common difference times n minus 1. Good? What do we know? Well, we don't know this. We don't know this. So we'll just leave it as a sub 1 plus